What is combination? This is just a fancy application of division rule. If you know division rule, you also know combination. Okay, so combination means C means combination, or I can say selection, or I can say unordered, or I can say set, committee, team. All these things are same. So this is just a fancy application of division rule. Here order does not matter. Here selection, we will select elements. It does not matter the order. The order will not matter to us. For example, number of ways to select 3 people from a class of 5 people. You want to select 3 people. The order does not matter. You just want to select them. You just want to select them. What do you think? What should be the answer? What should be the answer? It is hard, right? I think this is complicated. It seems complicated. Selection. Selection. It seems complicated. Life would be so good. Tell me, when life would be so good? When permutation is asked. If the question will ask us order, if the question will ask us order, how many ways to order 3 people? If the question will ask us to order, now life is very good. Yes or no? Can you notice life is very good? If the question asks us order, now life is good. Okay, so life is good. Okay, finally life is very good now. So the answer will be what? 3 people you want. You want 3 people. You want to order 3 people from 5 people. Now life is very good. Just apply the product rule and the answer will be basically 5p3, and that is nothing but 5 into 4 into 3. This is your answer. Okay, so the answer is 60. Life is very good. But because of this, what will change? Because of this, what will change? Because of this, what will change? Now you can notice that 3 things will act like 1. Okay, for example, let's assume these 5 people. Let's assume these 5 people are A, B, C, D, E. These are the 5 people. Now you can notice that now these things like ABC, ACB, BAC, BCA, CAB, CBA. Now these things, do they matter? Are they same or different? These things, are they same or different? They are same because we want to select. So now they are same as ABC. These things are same as ABC. Okay, so you can notice that if order matters, this is where order matters. So if order matters, means this is permutation, I can say. So this is your permutations. And what we want? We want selections, means we want combinations. We want selections. We want combination. Combination means selection. Another word of selection. So all these 3 things, all these 6 things, they will map to same. These are same. All of them are same. So finally, what will be the answer? Okay, so already you know number of permutations, you already know. How many permutations? 60 permutations. So how many combinations will be there? So that will be 60 divided by 6, that is 20. 60 divided by 6, that is 10. That is 10. So very simple. This is just a division rule. Can you notice? So if you already know permutation, if you have answer for permutation, this we have already seen, this is just product rule, then you can find answer for combination using division rule. Okay, so the idea is like this. So first you have this permutation. If you want to find the answer for permutation, then whose help will you take? Whose help will you take? You will take the help of product rule. Permutation is nothing but product rule. And if you want combination, then what will you do? On this permutation, you will apply division rule. On this permutation, you apply division rule and you will get combination. So very simple. Okay, so using product rule, division rule, you can find permutation also, you can find combination also. Let's see this question. How many ways to select R people? Only we want to select R people from N people. Then very simple. If you find permutation, you already know the answer. So how many permutations will be there? There will be total N, P, R permutations will be there. Okay, but we want combination. Actually, we want combination. And because we want combination, so you can notice that R things, A1, A2, AR. These things, they will have how many permutations? These things will have how, like this combination will have how many permutations here? This combination will have how many permutations here? It will have R factorial permutations here. Similarly, this combination like A2, A3, AR plus 1. Okay, so this also will have this selection. This selection will have R factorial permutations. Array, these are R elements. We only want R elements. We only want to select R elements. Remember, we only want to select R elements. Only this is what we want. So these are the permutation of, these are the R permutation, and this is A2 to AR plus 1. So these are R elements only. Okay, so this also will have R plus R factorial. So finally, I can say from permutation to combination, what we have? Which correspondence we have? We have R factorial to 1 correspondence. Very good. R factorial to 1 correspondence. Very good. Okay, so finally, number of combination, what that will be? That will be NPR divided by, that will be NPR divided by R factorial. And what we call it? इस पे R को क्या नाम दूं? What we call it? We call it NCR, right? Okay, so that's it. This is your proof. So finally, I can say this is another meme. So combination is nothing but division rule. Okay, and here you can write, if you want, basically you can write here that some permutation is going on. So on permutation you are applying the division rule. On permutation you are applying the division rule. Okay, so finally you will get combination. So this is your final result. So if you want to choose R elements, so remember this, if you have total n distinct elements, if you have, and from them, if you want to choose, you only want to choose R elements. If you want to choose, or I can say if you want to select, or if you want combination, all these things are same. So if you want to choose R elements, then how many ways are there? So if you want to choose R elements, then how many number of ways? Number of ways, that will be NCR. The number of ways will be NCR. Okay, so this is quite simple. So remember this, that yeah, so you have NCR, and this NCR actually, how do you read it? We read it N choose R. N choose R. This is how we read it. And let me tell you one thing. In ISC, actually, I took this course, this Combinatorics. So there were 2 courses in ISC. One was Combinatorics, another was topics in Combinatorics. In ISC, if you go, then for every course, whatever course you take, there is another course called topics in that. If you take any course X, then there is a course there. If you take course Y, there is another course topics in Y. Okay, so for example, if you have Combinatorics, then there is a course topics in Combinatorics. If you have graph theory, topics in graph theory, game theory, topics in game theory. So like this in ISC it happens. Okay, you will see next year, you will see this when you go to ISC, then you will see. So basically in this topics in Combinatorics, basically this is a research level course. This is completely research level course. In this this research course, means in this course, actually in this course we study books. In this course we study books, and in this course no book, there is no book that we study. In this course we study research papers. So basically the same course, like Combinatorics course, you will study books, and topics in Combinatorics, you will study research paper, back to back research paper. Like in 6 months, you will study almost maybe 10, 12, 13, maybe. Okay, if you finish one, next to second will come. That is your choice. Like if you want to finish 4, you can finish 4. If you want to finish 40, you can finish 40. There is no limitation. Okay, so this is the topics in the, so this is what happens in IS. Anyway, let me tell you that. So my professor, he never used this word NCR. Never. He never uses NCR. From his mouth, always this will come. N choose R. So actually, normally we use NCR, but in ISC, my professor, so he never used this. So this is what he was using. N choose R. Always N choose R, N choose R. Okay. So anyway, so this is the idea. So NCR, this is basically nothing but N choose R. And NPR, this is nothing but N permute R. So here, remember, here you are doing the permutation and here you are doing the selection. So the name itself is telling you. Okay. So for example, you can just see this is from Berkeley University. Let me tell you. This slide is from Berkeley University. All the slides that we use in our course, they are from some top university. So this slide is from Berkeley. So you can notice and choose out. Okay. So let's solve some questions. How many different committees you can create of 3 students from a group of 4 students? So that will be 4C3. So the answer will be what? 4C3. 4C3. And that is nothing but 4C3. If you find it, this is nothing but, I can say 4P3 you can find, divide by 3 factorial. Okay, you know what is 4P3? That is 4 into, so three terms. There will be 3 terms divided by 6. So the answer will be, okay, only 4. So you can just check it. Okay. So remember this note. So just note this. Actually, we will use in generating function. Why I'm like putting a stress on this? Because this thing we will use in generative function. I will ask you at that time when we study generative function. So remember, whenever you see this NPR, then just directly what you will do, how will you find it? You will find like this: n minus 1, n minus 2. How many terms? There will be total R terms. There will be R terms. So you will go down and you will get R terms. And how to find NCR? NCR is basically the same NPR divided by R factorial. The same NPR, do the NPR, okay, do the NPR R terms. So there will be R terms divided by R factorial. So this is what you will do in the NCR. So go down, from N you go down and there will be total R terms. These will be total R terms. And what you do, you divide by R factorial. This is your NCR and this is your NPR. Let's see this. How many poker hands of 5 cards can be dealt from a standard deck of 52 cards? So tell me, like there are 52 cards, you want to select 5 cards. See, in a poker game, does it matter? Like in a poker hand, order of card doesn't matter? Does it matter? In a poker hand, let me tell you that it's like this. Okay, so you have 5 cards and you are picking them. Okay, it does not matter the order. The order does not matter. In cards game, basically, in cards game, if you have in this cards game, there is something called hand. Hand means like how many cards you have. For example, if you have like if I deal you 13 cards, if I give you 13 cards, then you have 13 cards. That is called hand. Like what you have, what 13 cards you have. Okay, so here order doesn't matter. Let me tell you, here order doesn't matter. This is just a selection. Like exactly which cards you have, that matters. The order doesn't matter. Okay, anyway, next. So how many this poker is a game. So how many poker hands of 5 cards are dealt from a standard deck of 52 cards? This is basically from 52 you are selecting 5 cards. From 52 you are selecting 5 cards. Okay, and the another question, how many ways to select 42 cards? So from 52 you are selecting 47. From 52 you are selecting 47. Are they same? Are these two values same? Are these two values same? Let me tell you why they are same. Just think about it. See, just think about it. If you have total 52 cards, if you have total 52 cards, if I select 5 cards to, if I select 5 cards, then what it exactly means? Then that means if I select 5 cards, what it means? It means 552 C5. And if I'm selecting 5 cards, that automatically means I am rejecting the remaining cards. See, selecting 5 cards to keep, can I say this is same as selecting 47 cards to reject? Can I say this is same as selecting remaining cards to reject? Are they same? Yes, because if I'm selecting 5 cards to keep, so I'm selecting 5 cards to keep, it automatically means I'm rejecting this 47 cards. So selecting 5 cards to keep, that is same as selecting 47 cards to reject. So selecting 47 cards to reject means from 52, you are selecting 47 cards to reject. So both these things are same. So I can say, remember, from N if you are choosing R, from N if you are choosing R to keep, this means from N you are choosing R. This is same as from N you are choosing N minus R to reject. Okay, remember, it means I'm choosing R to keep, and here I'm choosing N minus R to reject. Is this clear? Both are same. So remember, NCR is always equal to NCN minus R. NCN minus R. And this is very important. So you can use it to reduce the number of terms. For example, I told you that if you want to find NCR, then what you will do? If you want to find NCR, then what you will do? R terms you will do, right? Total R terms you will do, divided by R factorial. But you don't have to do R terms. You can reduce the number of terms. For example, if I ask you 100 C 98, then there is one way. What is one way? 98 terms you will have to write. 100, 99, 98, 98 terms you will have to write. Yes or no? This will happen. 98 terms you will have to write, divided by 98 factorial. What is better? What is better? Better is, this is same as 100 C2, because NCR is same as NCN minus R. So now you only have to write 2 terms. Now you only have to write 2 terms. 199 divided by 2 factorial. So that is your answer. Okay. So this is the idea. So using this, you can reduce your number of terms. NCR is equal to NCN minus R, because here you are choosing R elements, and here you are rejecting the R elements. Selecting R element is exactly same as the rejecting N minus R elements. So both are same. And why 0 factorial is 1? I told you why 0 factorial is 1. Can anyone tell me why? I already told you why 0 factorial is 1. You already know. Can anyone give me correct answer? Why 0 factorial is 1? By definition, 0 factorial is 1 by definition of this factorial. So you can notice that this is your answer. Why 0 factorial is 1? The correct answer, if you notice the correct answer, that will be by convention. If you study any book, okay, on Stack Overflow, Stack Exchange, wherever you go, and you find this question, then one thing you will see, what is that? By convention, by definition. But actual question that you should ask, this question you should not ask. The question you should ask is, why this convention? See, 0 factorial is 1 because of convention. By definition of factorial, by definition, by convention, 0 factorial is 1. But the question that you should ask is, why this convention the mathematicians are using? Mathematicians are not like crazy. Okay, like they are not doing random things. Randomly, they are not doing that 0 factorial, let's make 1. No, they are not crazy. Okay, so what they want, see, there is a logic behind it. Tell me the answer for this. Forget about permutation combination. Tell me the answer here. Don't worry about permutation combination. Leave it. Tell me the answer here. Number of subsets of size 0. So number of subsets of size 0, what is that? Only one. Number of subsets of size 0, only one. Which subset? Which subset? Empty set, right? So number of subsets of size 0, only one subset we have, size 0, and that is your empty set. Number of subsets of size R. So you want to select, subset means select. You just want to select R elements. You just want to select R elements. So what will be the answer? Number of subset of, means you are selecting R elements. So you are choosing R elements, NCR, and choose R. Okay, this is your number of subsets of size R. So this is the idea. Now tell me, what should be again? Now, okay, so you know that number of subsets of size R, that will be NCR. Now tell me, number of subsets of size 0, what that will be? Now, what should be NC0? According to this NC0, what should that be? What do you think? NC0 should be 1? NC0 should be 1 because you told me that there is only one subset of size 0. You told me. So it means, and number of subset of size R, that is NCR. So NC0 should be 1. So NC0 should be 1. What is NC0? What is NC0? That is n factorial divided by n factorial, 0 factorial. This should be 1. So what should be 0 factorial? So from here, what should be 0 factorial? 0 factorial should be 1.